June 17th, 1944, Mid-Atlantic Ocean, approximately 30 nautical miles west of the Azores. Captain Lieutenant Helmut Sommer stood in the cramped control room of U-853, his fingers resting on the edge of the navigation table. Through the periscope lens, he could see nothing but endless grey water stretching toward the horizon under low clouds. The Type 9C submarine had been on station for 3 weeks, assigned to weather reporting duties, transmitting atmospheric data back to headquarters in France every 6 hours. The radio man looked up from his console, headphones pressed against his ears. Herr Kaleu, prepared to transmit weather report. Sommer nodded. The message had been prepared using the Kurzsignale code system, condensed into a brief sequence of encrypted letters. 25 characters. With an experienced operator, the transmission would take approximately 20 seconds. Standard procedure. Quick enough to avoid detection by the old British direction-finding equipment, which required nearly a minute to obtain a bearing on a radio signal. Within 10 minutes, aircraft from the American escort carrier USS Croatan would arrive overhead. Within 10 days, those same aircraft would locate U-853 again. Sommer and his crew had been taught that brief radio transmissions offered safety. They believed the ocean still provided concealment. They were operating with assumptions that had become obsolete months earlier, hunting them with technology they did not know existed. The transformation of the Battle of the Atlantic would not announce itself with dramatic revelation. It arrived through accumulated encounters, through close escapes that should not have happened, through destroyers that appeared impossibly fast after routine transmissions. German submarine commanders would spend the spring and summer of 1943 attempting to understand why the ocean no longer sheltered them, why Allied escorts seemed to anticipate their positions, why aircraft arrived within minutes of sending even the shortest signals. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The realization would come gradually, spreading through the U-boat force like cold water seeping through a failing seal. By mid-1943, seasoned commanders returning from patrol would gather in the officers' mess at Lorient, speaking in low voices about encounters they could not explain. Escorts that changed course directly toward their position immediately after transmitting. Aircraft that appeared from clear skies moments after surfacing to send mandatory reports. The mathematics of survival were changing, and no one at Befehlshaber der Unterseeboot headquarters in Paris seemed willing to acknowledge it. Between 1939 and 1945, German U-boats would sink approximately 3,000 Allied merchant vessels, totaling over 14 million gross registered tons. These losses nearly brought Britain to starvation, threatened the entire Allied war effort, and represented the closest Germany came to winning the war through purely naval means. But by May 1943, the balance had shifted irreversibly. That month, later known as Black May among submariners, 41 U-boats were lost, a quarter of the operational fleet. The exchange ratio that had once favored Germany collapsed. Instead of sinking 100,000 tons of shipping for every U-boat lost, the ratio fell to 10,000 tons per boat. Then lower. The weapon that helped accomplish this reversal was not a torpedo or depth charge. It was a receiver, an antenna array, and an oscilloscope display. High-frequency direction finding, called Huff-Duff by the sailors who operated it, could detect a U-boat's radio transmission and display the bearing to that transmission essentially instantaneously. 2 or 3 ships equipped with this technology could triangulate a submarine's position with accuracy sufficient to dispatch aircraft or surface hunters directly to the target area. It is estimated that HF-DF contributed to 24% of all U-boat sinkings during the war. When Captain Lieutenant Sommer took command of U-853 in June 1943, he inherited a vessel and a doctrine shaped by early war successes. The Type 9C was a proven design, displacing 1,144 tons on the surface and 1,257 tons submerged. At 76 meters in length, the submarine could travel 21,000 nautical miles without refueling, carrying enough provisions for patrols lasting 3 months. The boat mounted 6 torpedo tubes, 4 forward and 2 aft, with storage for 22 torpedoes, a single 8.8 centimeter deck gun, and anti-aircraft weapons provided surface armament. The crew numbered 48 men. These were not primitive vessels. German submarine design represented sophisticated engineering, informed by 2 decades of development since the Great War. Each boat featured complex trim systems for precise depth control, demagnetization equipment to protect against magnetic mines, and passive sonar arrays for detecting enemy ships. The diesel engines could propel the submarine at 18 knots on the surface. Submerged, running on electric motors, the boat could maintain 7 knots for extended periods or sprint at 7 3/4 knots for 1 hour before battery depletion forced surfacing. The men who crewed these submarines received extensive training. Sommer himself had completed submarine school, tactical courses, and supervised 2 patrols as executive officer before receiving his own command. His crew drilled constantly on emergency procedures, practiced silent running, studied convoy tactics, and memorized the recognition characteristics of Allied warship classes. They understood their equipment intimately. They knew how to calculate attack angles, how to read sonar contacts, how to interpret the sounds of distant propellers carried through ocean layers. What they did not know, what they could not know in mid-1943, was that their enemy had developed detection capabilities that rendered traditional submarine tactics nearly obsolete. The German Naval Command understood that radio direction finding existed. Admiral Karl Dönitz, who had commanded U-boats in the previous war and now directed the entire submarine force, knew that transmitting could theoretically reveal position. This awareness had driven the development of Kurzsignale, the short signal code system designed specifically to minimize transmission time below the threshold required for conventional direction-finding equipment to obtain a bearing. The Kriegsmarine's assumptions about Allied capabilities were based on technology they themselves possessed. German direction-finding equipment used the Bellini-Tosi system, which employed a rotating loop antenna that had to be physically turned until the operator detected a null in the signal strength. This process required time, typically 1 minute or more for an accurate bearing. A transmission lasting 20 seconds would be finished before the operator could complete the measurement. Therefore, logic suggested, brief signals offered protection. This calculation was correct regarding the technology Germany knew about. It was catastrophically wrong regarding the technology Britain and America had deployed. By mid-1942, Royal Navy escorts were being equipped with shipboard HF, DF sets that required no mechanical rotation, no manual searching for signal nulls. The British system used an array of fixed antennas connected to a cathode ray oscilloscope display. When a transmission occurred, the display showed the bearing immediately as an elliptical pattern on the screen. An experienced operator could read the bearing in seconds. 2 ships with this equipment could cross-reference their bearings and establish the transmitting submarine's position with useful accuracy. 3 ships could triangulate precisely. The technology had evolved from research conducted in the 1920s by Robert Watson Watt, who had been attempting to develop a system for tracking lightning strikes to provide storm warnings to pilots. His apparatus used the Adcock antenna design, 4 vertical elements arranged in a square pattern, which received signals with minimal distortion from ground reflection. Connected to an oscilloscope, this system could display the direction to any electrical discharge instantaneously. Watson Watt's work remained relatively obscure until the late 1930s, when British naval intelligence recognized its potential application against enemy submarines. The first HF, DF installations appeared on Royal Navy vessels in 1941. Production increased throughout 1942. By June of that year, the United States Navy had begun a program to equip half of all new destroyer escorts with HF-DF systems. These installations proliferated rapidly. The shore-based network of direction-finding stations around Britain, Iceland, and North America provided strategic intelligence on U-boat movements across the Atlantic. The shipboard systems provided tactical intelligence, allowing convoy escorts to respond immediately to any submarine that transmitted within detection range. Grand Admiral Karl Dönitz directed the U-boat war from headquarters outside Paris with meticulous attention to operational detail. His command style emphasized central control, with U-boat commanders required to report their positions, fuel status, torpedo expenditure, and convoy sightings regularly. When a submarine located an Allied convoy, standard procedure required the boat to shadow the formation while transmitting contact reports that would allow Dönitz to concentrate other submarines in the area into a Wolfpack for coordinated night surface attacks. This tactical approach had proven devastatingly effective during the early war years. Between 1940 and 1942, coordinated Wolfpack operations sank hundreds of Allied merchant ships. The system worked because Dönitz could position his submarines across probable convoy routes, using radio communication to mass forces at the critical point. One submarine would locate the target, others would converge, and the pack would attack together, overwhelming the escorts through superior numbers. The doctrine required radio communication. Without regular position reports, Dönitz could not coordinate operations. Without contact reports, he could not concentrate forces. Without tactical signals, Wolfpack attacks could not be properly sequenced. The entire operational system depended on U-boats transmitting from sea. Dönitz understood this created vulnerability, but he believed the Kurzsignale system provided adequate protection. The messages were brief. They were encrypted using Enigma machines before transmission. The submarine commanders were instructed to transmit quickly and minimize radiation of signals that might be detected. What Dönitz and his staff did not fully comprehend until too late was that the Allied direction-finding network no longer needed long transmissions to obtain useful bearings. A 20-second Kurtz signal was more than adequate for HFDF operators to establish position. Multiple transmissions over several days created a pattern that convoy routing authorities could use to direct merchant ships away from U-boat concentrations. Even a single brief signal could trigger an immediate response from nearby escorts equipped with shipboard HFDF, bringing destroyers or aircraft to the transmission point within minutes. The German naval staff received warnings. Some U-boat commanders returning from patrol reported suspiciously rapid responses from Allied escorts after routine transmissions. Intelligence analysts noted an uncomfortable correlation between radio signals and subsequent attacks, but accepting that the Allies possessed instantaneous direction-finding capability would require abandoning the entire operational doctrine that had achieved success during 1940 through 1942. It would require admitting that the enemy held a decisive technological advantage. It would require fundamentally restructuring U-boat tactics away from coordinated Wolfpack operations toward individual patrol. Dönitz resisted this conclusion. In August 1943, after losses had mounted catastrophically during the spring and summer, he issued a current order to his submarine commanders, attempting to explain the situation. The message acknowledged that the enemy had developed effective methods for locating U-boats through their radio transmissions, possibly using long-range reconnaissance aircraft in combination with direction-finding equipment. The order tightened radio discipline further, demanding that commanders transmit only when absolutely necessary, use off frequencies when possible, and maintain strict silence during rendezvous operations. But the order could not, eliminate radio communication entirely. The operational system still required position reports, weather data, convoy sightings, and tactical coordination. U-boats still needed to receive orders from headquarters. The basic architecture of centralized command and Wolfpack tactics remained unchanged, which meant the vulnerability remained unchanged. The submarines would continue transmitting, and the Allies would continue tracking them with technology the Germans could neither match nor effectively counter. By late 1943, experienced U-boat commanders understood they were being hunted through methods they could not see. They knew that transmitting attracted danger. They recognized that Allied escorts responded with uncanny speed and accuracy after radio signals, but they received orders from Dönitz demanding continued operations, continued reporting, continued attempts to locate and attack convoys. The boats sailed, the radios transmitted, and the casualties accumulated at rates that exceeded shipyard production capacity. The faith in brief transmissions, in encrypted signals, in the protection offered by speed and stealth, had been rendered obsolete by a technology few German sailors fully understood. The ocean that had once sheltered submarines had become a surveilled medium, where every radio pulse potentially marked position for enemies equipped with instantaneous detection equipment. The transformation was complete, though many submarine crews would not fully comprehend what had changed until they heard the sound of aircraft engines overhead moments after their radio man finished sending a routine weather report. The encounter that would demonstrate HF-DF's capabilities to Sommer and his crew occurred on June 17, 1944, though they would not understand what had happened until much later. At approximately 1100 hours, U-853 surfaced to periscope depth and raised her radio antenna. The radio man transmitted the scheduled weather report, a curt signal of 25 encrypted characters taking 19 seconds to send. The message contained atmospheric pressure readings, wind direction and speed, sea state, and cloud cover observations required by German meteorological services attempting to predict conditions over the Atlantic. 30 nautical miles away, aboard the escort carrier USS Croatan, a high-frequency direction-finding operator watched his oscilloscope display. The moment U-853's transmission began, an elliptical pattern appeared on his screen. He aligned a cursor with the peaks of the display, noted the bearing, and called it out to the watch officer. 285 degrees. The bearing was immediately plotted on the chart table. Within 90 seconds, 3 aircraft had been launched. The TBF Avenger torpedo bombers carried depth charges, acoustic homing torpedoes, and enough fuel for a 4-hour patrol. Sommer ordered the submarine to dive immediately after the transmission finished. Standard procedure. U-853 descended to 70 meters and proceeded at 4 knots, changing course to complicate any pursuit. The crew secured from radio watch and returned to routine patrol operations. They had transmitted for less than 20 seconds. By their understanding of Allied capabilities, this should have provided safety. 10 minutes later, the sonar operator reported distant propeller sounds, aircraft, multiple engines. Sommer ordered silent running, all non-essential equipment shut down, movement minimized. The submarine settled to 90 meters. Through the hull, the crew could hear the aircraft circling overhead. The sound of their engines transmitted through the water. The planes remained on station for 3 hours, dropping sonobuoys in a search pattern, waiting for the submarine to surface or make noise that would betray position. Eventually, as fuel ran low, the aircraft departed. U-853 remained submerged for 6 more hours, finally surfacing after dark to recharge batteries and refresh air. Sommer filed a report of the incident upon return to base, noting the unusually rapid aircraft response following routine transmission. His report joined dozens of similar accounts from other commanders. The pattern was becoming undeniable. Something had changed in Allied detection capabilities. The technical specifications of the equipment hunting U-853 represented a generation beyond what German intelligence assessed the Allies possessed. The shipboard HF-DF installation aboard Croatan and her escorts used the DAQ system developed by French engineer Henri Busigny's and refined by American naval laboratories. The receiver could detect radio transmissions across the high-frequency band from 3 to 30 MHz. The Adcock antenna array, mounted on a rotating platform for calibration purposes but requiring no rotation during operation, fed signals to a cathode ray oscilloscope display, with a circular screen approximately 12 centimeters in diameter. When a transmission occurred anywhere within several hundred kilometers, assuming line-of-sight radio propagation, the display showed an elliptical pattern oriented along the bearing to the signal source. An experienced operator, trained in a 3-week course that covered radio theory, antenna characteristics, signal propagation, and practical exercises, could read the bearing within 5 seconds of signal detection. The accuracy ranged from 2 to 5 degrees depending on signal strength and atmospheric conditions. Multiple ships obtaining cross bearings could establish position within a circle approximately 15 to 30 kilometers in diameter, sufficient to guide aircraft or surface hunters to the target area. By June 1944, approximately 200 Allied warships carried HF-DF equipment,